Welcome dear students. In this lecture we are going to talk about the Friedel-Crafts reaction. These are named after the two chemists who introduced these reactions. And the Friedel-Crafts reactions, they are of two types. One is the FC alkylation, which includes the introduction of the alkyl group to the benzene ring. And the second one is the FC acylation, in which acyl group is introduced to the benzene ring. My dear students, in FC alkylation, the benzene is made to react with any alkyl halide in the presence of aluminium halide. My dear students, the hydrogen of the one corner of the benzene, it joins with halogen to form HX, and finally you will get the alkyl benzene, and you have introduced the alkyl group to the benzene ring. The catalyst which is used in this reaction, because its octet is incomplete, so it is basically a Lewis acid. You know that aluminium belongs to group 3, so it has 3 electrons in its valence shell, and 3 electrons are shared by these 3 halogen atoms. So it will be having total 6 valence electrons. This is an example of the contraction of the octet, and it can accept a lone pair of the electrons, so it will be acting as a Lewis acid. Now my dear students, let us talk about the mechanism of Friedel-Crafts alkylation. The first step, that will be generation of strong electrophile. As benzene is highly stable, so a weak electrophile cannot attack the pi electrons of the benzene, which are the delocalized electron. So a stronger electrophile will be required to attack the delocalized pi electrons of the benzene. And the strong electrophile is generated by the reaction of the reagent and catalyst. The reagent is alkyl halide and the catalyst is aluminium halide. So they react together, and halogen takes both of its electrons and it forms AlX4 negative and R positive. My dear students, this AlX4 negative, that will act as a Bronsted base in this mechanism, and it will accept proton, and this one is alkylium ion, that will act as a strong electrophile. And my dear students, in this alkylium ion, as the positive charge will be on carbon, so it is an example of the carbocation or carbonium ion. So you can say that carbocation or carbonium ion is the strong electrophile in Friedel-Crafts alkylation. And my dear students, this carbocation is very important in determining the nature of the product of the Friedel-Crafts alkylation, as the less stable carbonium ion can be changed to a more stable carbonium ion, and the product as compared to expected, that can change. We are going to discuss it in this lecture in detail. Second one is the attack of strong electrophile on benzene. And when this strong electrophile will attack the benzene, cyclic carbocation is generated. It attacks the benzene. This is the hydrogen present at this corner, and the alkyl group is also introduced, and this is again a carbonium ion or carbocation, and this is an example of the secondary carbonium ion, because this carbon, which is positively charged, is attached to two other carbon atoms. In the last step, that will be regeneration of catalyst. As catalyst is never used in the reaction, and if during the mechanism the catalyst is used, then it must be regenerated at the end of the reaction. And the role of the catalyst in all electrophilic substitution reactions of the benzene is just to facilitate in the production of the stronger electrophile by reacting with the reagent. And in the regeneration of this catalyst, the Bronsted base that will play its role, which was produced in the first step. My dear students, this Bronsted base will attach the hydrogen with it, and the bond which was present between carbon and hydrogen, now that will be shifted between two carbon atoms in the ring. This H positive and X negative, they will combine to form HX. The catalyst is regenerated, and finally you will get the alkyl benzene. So these are the three steps of the Friedel-Crafts alkylation. Now, my dear students, if you want to quote some example of this reaction, that will be very simple. As this is benzene, this one is methyl chloride. Just specify the halogen atoms and the alkyl groups in the presence of AlCl3. You will get HCl, and that is toluene or methylbenzene. So this is an example of the Friedel-Crafts alkylation. Now, my dear students, there are some drawbacks of the Friedel-Crafts alkylation. And what are those drawbacks? Number one, when a single alkyl group is introduced to the benzene ring, it becomes very difficult to stop this reaction at this point, and there might be more alkyl groups that can be introduced to the benzene ring. So instead of the monoalkyl benzene, the dialkyl benzenes or trialkyl benzenes are produced. So this one is the first drawback, that this reaction is difficult to stop once the one methyl group is or one alkyl group is introduced to the benzene ring. As the alkyl groups, they keep on adding into the benzene, and you will get the dialkyl benzene or trialkyl benzene. And my dear students, there is another drawback of this Friedel-Crafts alkylation, and that is very important. Suppose if you are going to add the this is benzene, and N-propyl chloride is added to the benzene in the presence of AlCl3. What happens? You are expecting that your product will be N-propyl benzene with HCl, but my dear students, in this case, this N-propyl benzene is not created. Why? As I have already mentioned during the mechanism of the Friedel-Crafts alkylation, that in the first step, the R positive is generated. Carbocation is generated, which acts as a strong electrophile. In this case, normal propyl carbocation is generated when this bond is broken down, and as it is a primary carbocation, it will be highly unstable, so it will be rearranged to the secondary carbocation, which is more stable. When this primary carbocation will be rearranged to the secondary carbocation, then instead of getting the normal propyl chloride, normal propyl benzene, the exact product will be isopropyl benzene, because during the mechanism, when normal propyl carbocation will be produced, it is a primary carbocation, it will be unstable, that will be rearranged to a more stable secondary carbocation, and this secondary carbocation then will attack the benzene, and you will get the isopropyl benzene, which is also called as the cumene. So the second drawback is that you can prepare the methyl benzene, ethyl benzene, or tertiary alkyl benzenes by using the Friedel-Crafts alkylation, but to produce the N-propyl benzene or the benzene alkyl derivatives of the benzene in which the carbocation has the option of the rearrangement, then you will not get the required or expected product. So that was the second drawback of the Friedel-Crafts alkylation. Now, my dear students, the next part of the Friedel-Crafts reactions, that is the Friedel-Crafts acylation. Now, let us discuss Friedel-Crafts acylation, in which acyl group is introduced to benzene. This is benzene, and we have acyl halide, or it is called as acid halide, that will made to react with benzene, and the catalyst will remain same, that is aluminium halide. Again, my dear students, the hydrogen present at any one corner of the benzene, that will join with X, and you will get HX, and then this acyl group gets attached to the benzene, and my dear students, you will get an aromatic ketone. So an aromatic ketone is produced basically, and this aromatic ketone, if required, that can be reduced by using the Clemmensen reduction, and it can also be changed to some alkyl benzene. Now, my dear students, this was the general reaction. What should be the mechanism of the Friedel-Crafts acylation? The mechanism will remain same. In the first step, the reagent, which is an acyl halide, it will react with catalyst aluminium halide, and it will form a Bronsted base, and again a carbocation is produced that will act as a strong electrophile. Now, this strong electrophile in the second step, just as we have already discussed in Friedel-Crafts alkylation, that will attack the benzene ring, and you will get a cyclic carbocation. This one will be an example of a secondary carbocation. And now, my dear students, in the last step, there will be regeneration of catalyst, the Bronsted base that will join the hydrogen with it, and the bond which was between carbon and hydrogen, that will be shifted inside the ring. You will get HX plus the catalyst ALX3 is regenerated, and finally the product will be an aromatic ketone. So that is the Friedel-Crafts acylation. If you want to quote an example of the Friedel-Crafts acylation, then the benzene is made to react with acetyl chloride in the presence of AlCl3, and you will get acetophenone or methylphenyl ketone. That is the acetophenone. My dear students, there was a drawback of the Friedel-Crafts alkylation, that the N-propyl benzene cannot be prepared. So that N-propyl benzene can be prepared by Friedel-Crafts acylation, in which Propanoyl chloride will react with benzene in the presence of AlCl3 after the release of HCl. Now you will get the ethyl phenyl ketone. And this ethyl phenyl ketone is then reduced by using the Clemmensen reduction, zinc with HCl that will reduce this carbonyl group. After the loss of water, you will get the N-propyl benzene. So this Friedel-Crafts acylation is important because, as we have already studied, that in the Friedel-Crafts alkylation, methyl benzene, ethyl benzene, and tertiary alkyl benzenes can be prepared. So this can be used to prepare the alkyl benzenes like N-propyl benzene. So N-propyl benzene cannot be prepared by Friedel-Crafts alkylation due to the rearrangement of the carbocation from primary to secondary, but that can be prepared by using the Friedel-Crafts acylation, in which first a ketone is prepared and then the Clemmensen reduction of the ketone that results in the formation of the N-propyl benzene. And my dear students, alkyl benzenes, you know, they can also be prepared by the action of the alcohols on the benzene in the presence of some, you can say, mineral acid like H2SO4, and there are some other methods of the producing alkyl benzenes, but it was all about the Friedel-Crafts alkylation and Friedel-Crafts acylation. Next time we will come up with some new lecture. Till then, take care.